So I was going to talk about my BFF today. Unfortunately, my BFF wasn't able to be here. If anybody wants to come up, I'll talk about you for the next half hour. How about that? No, no. um, no, my BFF is a tool I wrote, and it's kind of sad, but over the last 6 months or so, I've probably spent more time with this tool than I have with my actual BFF. But I guess that's just the information security industry, right? So, like we announced, I'm Kirk. I'm a husband. I'm a father. I have two great kids at home, a beautiful wife at home. I'm also a geek, of course, probably like everybody else in here. I'm a security consultant for Rapid7 doing penetration testing. I've created a few different open source tools. Backhack might be one of the more popular, if you will. It's a Android application file system analysis tool for non-rooted devices, so you can actually access the file system, and it's great for showing risk to customers, but it's also great for giving your wife unlimited lives in Candy Crush. Actually, the reason I wrote it. She stopped playing pretty quickly after that. She said it got boring. I've been in IT for about 13 years, the last 4 in penetration testing specifically. I also blog on the community site for Rapid7, so you can check that out if you want. So today, we're going to talk about different authentication methods. I'll start off there. This is kind of the more basic stuff. You'll see the kittens and at least one dog in there. I didn't want to offend either side. I don't want to choose a side on the kitten versus puppy debate, although I am a dog person more. We'll then go into techniques for attacking authentication, specifically passwords. That's why we're here. We're going to talk about web application login forms. My BFF is a tool for attacking login against web applications currently. It will be expanded to other protocols as well. We'll talk about kind of tools that are out there for web application testing and guessing their strengths and weaknesses, and then I'll talk about my BFF. We'll get into deep into that, how that works, the different modules, what you can do to add into it if you want. I'll do a quick demo on its functionality, and then we'll talk about mitigations for these kinds of attacks, since we really want to be able to protect against those. So different authentication techniques. First one up, biometric. It's something that you have fingerprints, retinal scans, voice recognition, facial recognition. Biometrics kind of about 10 years ago, I was working for a company. We wanted to implement biometrics. It was just technology wasn't as good then. It was also very cost prohibitive. But something changed in the last 2 years or so. Anybody know what that is? It's kind of bringing biometrics to mainstream. That's right, iPhone. Android phones, if you have one within the last 2 years, most likely has a fingerprint reader. Mine doesn't, it's old. But biometrics is great. It makes it very easy to log in, and we're seeing more than just logging into your phone with biometrics now. A lot of bank apps and stuff are starting to implement those biometrics, which is great. This cat is actually using biometrics to log into its computer right here. If you didn't know, cats have a unique forehead print. It's kind of like a zebra, and they can authenticate that way. That was totally made up. Just kidding around. The other thing we have is a PIN, personal identification number. It's usually 4 digits, could be longer. We use it to log into phones. You use it to log in when you want to get money from the ATM. You have to use your PIN. Don't do that here. I wouldn't trust any ATMs, not with all of you people around. But PIN numbers are great. Log into your phone with it. You could also use PINs as a second factor if you think about it, right? Your RSA tokens, your Google Authenticator, essentially that's a PIN. It's a unique ID that you have. And that's what I think PINs are best used for as a second factor, not a primary. If it's 4 numbers, you only have about 10,000 possibilities, and it's pretty easy to brute force and figure out. And lastly, we have usernames and passwords. By far the most common. You use it to log into everything. Computer, your bank account, different web applications, different protocols. We use it everywhere. And so usernames are easy to get, right? How do we get usernames? Anybody?
We just asked the users.
We just ask the users. We could scrape LinkedIn for the data. I find more and more on tests that companies are putting their entire directory structure, all the employees on their websites. I'm not sure why, but they think it's not a risk, and that's fine if that's what their decision was, but it makes my job very easy. And in the worst case scenario, when it's hard to find, we just use census data. We run against some kind of timing attack, against some kind of service, and gain a bunch of usernames. Passwords become a little harder. Realistically, people are pretty predictable with their passwords, right? So those are usually pretty easy to guess, but we have a couple different ways to figure out what those passwords are once we have usernames. First is brute force. Like this kitten, it used brute force to get through this wall, just kept pounding in one spot until it got through. Brute force is as many passwords as we can throw at an account until we get in. Simple. Password spraying, here's the puppy. Password spraying is kind of the inverse of brute forcing, right? Instead of brute forcing a password against the user, we're brute forcing users against a password. I'm going to try thousands of usernames against one password, and likely I'm going to get in. And that's going to do one major thing, which is prevent account lockout. And to understand the account lockout, we'll look at online versus offline. Online, any service that's authenticating and checking with the database, real time, they usually have an account lockout policy. And so we want to use password spraying. We don't want to lock out accounts. That's going to cause a denial of service, and we're not going to get in. We want to get in, right? So if we're an online service, such as a web application, we're going to use password spraying on that. Whereas offline, there's no risk of account lockout. But we need something for offline guessing. Anybody know what that is? Hashes, right? So how do we get hashes? There's numerous ways. But once we get that hash, we can use brute force, whether it's dictionary attack or pure brute force, trying every single combination possible. And there's some tools that we have to try those things. Like I said, we're going to focus on web applications, and so that's online. So we'll focus on password spraying for the most part. Web application login forms are very straightforward and simple. They all are common. They all have three common components. You have your username, your password, and a submit button. It's essentially all there is. The username field, the password field, they can change names. They can be completely unique, whatever they want. But this is essentially what a web app login form looks like. This is one I created in probably 30 seconds. So the submit button is going to take whatever is the username and password as a payload and submit it to the form, to the page it's going to. And that'll do a check on the database and return a valid or invalid response. So we have different tools to check on this. First up is Burp Suite. I highly recommend Burp Suite. If you don't have it, go get it. But it's very manual. That's the only problem with Burp Suite. I need to review the traffic. I need to figure out what the username field is, what the password field is. And then once I run Intruder, now I need to go back and look at what's an invalid versus a valid response. That's okay for one-offs, but if you're doing that test after test after test on this different or the same web apps, it's a little bit of a pain. So there are scripts written in different languages, but these scripts are specific to one kind of application, right? There may be a Citrix portal that you're trying to get into, and you can run a script and it'll tell you if it's valid or invalid. But if that Citrix portal changes, which there's multiple different versions, and every couple of years, Citrix seems to change all their code. Well, now I need a new script, and that could be a pain. So I created my BFF. What is my BFF? It's a brute force framework. It's modular, so we can just easily add new modules for different web applications or even different protocols. It's intelligent. And what I mean by that is I don't want to have to pick out and choose what the username field is, what the password field is, what the valid response is. I don't want to have to put all that in. I just want it to figure out what kind of application it is, pointing at a URL, find out what application is, call the right module, and just give me the information. And it goes beyond just brute forcing, and that's kind of the secret sauce on this. And I'll get into that more in a little bit. Currently, I have about 5 modules. There's some of them up there. So for each module, first we're going to fingerprint. We're going to find out what kind of application this is. This could be many different ways. It could be a URL. It could be a string within the body of the response from that page. It could be a cookie value. Anything that separates that application or that protocol apart from others. We'll fingerprint off, and then we'll call a module. And in the module, first thing is the payload. Like I said, that username and password can be different. It could be username, it could be user underscore name, it could be J underscore username, it could be user dot name, it could be user, it could be something totally different. So we create that payload, and then once we do that, we're going to do a connect test. And this is where scripts at this point stop. We're going to tell you if it's valid or invalid, and that's great, but I want more. And so lastly, we're going to do something cool with that. To explain that, about 6 months ago when I was starting to create this tool, I was on an external engagement for a customer and doing my testing, and enumerated about 3,000 or 4,000 usernames off a flaw they had on one of their apps. And then I needed to do password guessing, right? So I ran through with my favorite password, season and year, right? So at the time it was spring 2016. How many use that password? Yeah, all right. Hopefully not, but it's a very, very, very common password that we see everywhere. So I have about 15 valid accounts at this point after using that. And they have a Citrix portal. I love Citrix because I can escape it pretty easily. And once I escape the Citrix sandbox, now I have internal access and get to destroy the internal network. So I tried with the first account, and the response from the page was there's no applications assigned to this user. So, all right, try another one. Try the second one. No valid applications assigned to this user. Third one, what do you think that was? No valid. Okay. 4th, 5th, 6th. I got to the 7th or 8th, and I said, this is ridiculous. There's got to be a better way to do this. So I ended up scripting out the whole thing, ran through all 15, and every single one didn't have any applications. So at this point, I'm like, this kind of sucks. But now I have a script. Run that script, and using my second favorite password, company name 1234, and ended up getting 3 or 4 with that. And one of them actually had applications. So get in, escape the Citrix environment, get internal access, end up owning the entire domain. They had multiple domains and took all that over. So it was very successful on my part. And that's what I mean by going beyond. So each module is going to do something different, and that's going to depend on the module, on the web application, or on the protocol. For the Outlook Web Access and OWA and Office 365, we're going to parse the email. We're going to look for sensitive information. We're going to print that out for you. And we're also going to pull out all the contacts and save that off. For the Citrix, we list those apps out. So now I can tell if it's a Internet Explorer browser, a third-party application, or a full Windows desktop, and I can decide which one I want to attack. For Juniper, we do something cool before the authentication. Often Juniper has multi-factor enabled, but we can usually bypass that depending on how it's set up. So we'll attempt that bypass. We'll see if that works, and if it does, then we'll do our brute forcing against that. And so each module is like that, something different. So we'll go into a quick demo, just a little bit of that. And it might be, if it's a little small, I can zoom in on it for you. But to start off, we're going to just run Python my BFF. We're going to pass it the host. Now the host has to include the protocol that you're going to use, in this case HTTPS, and the IP or the host name that you're going to attack. The capital U is for a user list, and so this list has a few users. And the P, lowercase p, is for a single password. Again, one of my favorite passwords to try. This particular app actually failed. It's a small business server, and so if you don't know, small business servers, when you go to the initial web page, it redirects you to a virtual host, which is remote web workplace, where you can remote control all the systems inside. For this, I want to attack OWA, which is /OWA. So we're going to rerun this, clear this out. We'll rerun this using a vhost option. The vhost option is going to we're going to add in the OWA so we can specify that specific host. And after we run this, we'll see that it finds that it's an Office 365 or OWA server. And then it tries password guessing. We'll find that user 3 was successful with Spring 2016. We then search for sensitive emails, looking for keywords such as password in there. We find that there's some password helps emails from the domain admin, and it's kind of sad that the domain admin actually has the same password. So good job there. And you'll notice at the bottom, we take any contacts and we add it to a file under temp, and then contacts dash, and then the username, and that splits that out. So now we can use this information to do other attacks, such as phishing attacks, or just trying to email through that, or more password guessing, things like that. Now the second module, last year I found a 0-day in a HP SiteScope application. SiteScope is a application that allows you to monitor your system, servers, network from this web console. And so they had a exploit in that, and so this is the module for that. So we run my BFF again. This time the host is actually, the service is running on port 8080. So once we put in the URL, we add the port, and it's not a separate option. It's all within that host. The module is going to call a Metasploit module that will then exploit and get us a shell through this DNS tool lookup, where we have command execution. And in this case, we're going to use a lowercase u. We're going to try one user and one password, admin and password. And we'll run this. And we'll see it's successful. It's going to call that Metasploit module. It's going to run through. Once it loads up, we've got our interpreter shell. And we'll run getUID to see who it's running as, and we see it's NT Authority system, which is great. Now we have access to go beyond with that. So the MyBFF is going to be available today, right after this presentation. It'll be located on the Moose Dojo GitHub page, so go check that out. I'll be adding more modules as I go. Currently, I have plans for WordPress, Cisco VPNs, and a couple other web apps, as well as SMB, FTP, Telnet, SSH, and other protocols as well. So a lot of cool things coming. And each one of them is going to do something different, right? Well, that's the whole point of this, is I don't want just to know if this is, if the username and password is correct. I want to be able to have it do something with it. And who knows what else. And so if you have ideas, let me know. I'd love to talk to you about that. And so we have password attacks. How do we protect against that, right? What good is knowing that you can get attacked on your passwords if you can't do anything about it? The first thing is we want to detect. Detection is key. Organizations that can't detect these kinds of attacks or attacks against them are going to fail. And so if you can put in place brute force detection, and whether that's password spraying or brute forcing against accounts within, if it's a Windows domain, it's easy, it's all built in. You can just enable those kind of thresholds in that monitoring. So it's all right there. Second is multi-factor authentication. As long as you're implementing it correctly, and there's not a bypass like the Juniper often has, this drastically reduces my ability to attack your system. I need that second factor now. So now I need to social engineer an employee, or I need to some other way gain access to that second factor. And then lastly, strong passphrases are key. If your password's long, complex, I'm not going to be able to guess it easily, and I'm not wanting to brute force to lock out your account, so it's going to make things much harder for me. So that's everything. This is my contact information, both my personal GitHub as well as the Moose Dojo where my BFF is. If there's questions, I'd love to take them. If not, we can talk later. I'd love to meet you guys.
How many Metasploit modules do you have integrated with this? Is it just the one, or?
Yeah, so for Metasploit modules, it's just the one. It's the HP site scope that I've written. It'd be easy to add as modules go, but yeah, but that's the only one we have currently.
Do you have like an optional switch to specify like an RC file?
I don't. Currently, it writes out the RC file and then calls that RC file to run everything. Those are things that might be worth looking into and adding though. So.
Okay, so we're going to move on to the next speaker, so I have to cut it off there. Just want to remind people also about one of the manner rules of PasswordsCon. We are doing this for good, so any tools and any techniques being released and mentioned here at the conference, use them for good. If you use them for evil, I will tell you two things. Number one, I do not believe in violence. Number two, I really know a cool party trick, and that is I can delete your social security number, okay? So thank you, Kirk. Really interesting, and the tool is available online.